Imagine controlling a computer, smartphone, robotic arm, or even a wheelchair using nothing but your thoughts. No keyboard, no mouse, no touchscreen, just your brain. What once seemed like science fiction is quickly becoming reality through one of the most revolutionary technologies of the 21st century, brain-computer interfaces, also known as BCIs. In 2027, brain-computer interface technology is advancing faster than ever before. Scientists, engineers, and technology companies around the world are working to create direct communication between the human brain and computers. This breakthrough could completely transform healthcare, education, communication, gaming, robotics, artificial intelligence, and even the way humans interact with machines. So, what exactly is a brain-computer interface? A brain-computer interface is a system that creates a direct communication pathway between the human brain and an external device. Instead of using physical movements like typing on a keyboard or clicking a mouse, the computer reads electrical signals produced by the brain and converts them into digital commands. Every second, billions of neurons inside the human brain communicate through tiny electrical impulses. These signals control everything from movement and speech to memory, emotions, and decision-making. Brain-computer interfaces detect these signals using advanced sensors and sophisticated artificial intelligence algorithms that translate brain activity into meaningful actions. There are two main types of brain-computer interfaces. The first is non-invasive BCIs. These systems use wearable devices placed outside the head, such as special helmets or headbands equipped with sensors that measure brain activity. Because they do not require surgery, they are safer and easier to use, although they usually provide lower signal quality. The second type is invasive BCIs. These involve tiny electronic implants placed directly inside or on the surface of the brain through surgery. Since these implants are much closer to neurons, they can capture more accurate signals and provide greater control. However, they also involve higher medical risks and require careful monitoring. One of the most important applications of brain-computer interfaces is healthcare. Millions of people around the world suffer from paralysis caused by spinal cord injuries, strokes, or neurological diseases. Many of these individuals lose the ability to move or communicate independently. Brain-computer interfaces offer new hope by allowing patients to control robotic arms, prosthetic limbs, computers, and communication devices using only their thoughts. Imagine someone who cannot move their hands being able to type messages, browse the internet, or control a robotic wheelchair simply by thinking. For many patients, this technology could dramatically improve independence and quality of life. BCIs may also help restore communication for people affected by conditions such as ALS or locked-in syndrome. AI-powered systems can analyze brain signals and convert intended speech into written text or synthetic voice output, allowing patients to communicate with family members once again. Brain-computer interfaces are also changing the future of prosthetic technology. Traditional prosthetic limbs often require complicated controls and extensive training. Advanced BCIs allow artificial arms and legs to respond directly to brain signals, making movement feel more natural and precise. Future prosthetic devices may even return sensory feedback, allowing users to experience touch, pressure, and temperature. Another exciting field is rehabilitation. After brain injuries or strokes, many patients require months or even years of physical therapy. Brain-computer interfaces combined with artificial intelligence can monitor brain activity during rehabilitation exercises, helping patients retrain damaged neural pathways more effectively and potentially speeding up recovery. Education could also be transformed. Future learning systems may use brain-computer interfaces to monitor attention, concentration, and learning progress in real time. Educational software could automatically adjust lessons based on each student's cognitive performance, creating highly personalized learning experiences. Gaming and virtual reality are expected to become even more immersive. Imagine entering a virtual world where your character moves simply because you think about moving. Instead of using controllers, future games may respond directly to your brain activity, creating incredibly realistic and interactive experiences. The entertainment industry is also exploring BCIs for creating new forms of digital interaction. Movies, music, and virtual experiences may adapt dynamically based on a user's emotional responses detected through brain signals. Artificial intelligence plays a crucial role in making brain-computer interfaces possible. Brain signals are extremely complex and differ from person to person. AI algorithms analyze enormous amounts of neural data, recognize patterns, filter noise, and learn how each individual brain functions. Machine learning continuously improves the accuracy of brain signal interpretation, making BCIs more reliable over time. Communication may also undergo a revolution. Researchers believe that future brain-computer interfaces could eventually enable direct brain-to-brain communication, allowing people to exchange thoughts, emotions, or ideas without speaking. While this remains experimental, it represents one of the most fascinating possibilities for future human communication. The workplace could also change dramatically. Professionals may control multiple computer systems simultaneously through thought alone. Engineers could design complex machines mentally. Surgeons might operate robotic medical systems with incredible precision. Pilots, astronauts, and industrial operators could interact with advanced technologies faster than ever before. Military organizations are also investing in brain-computer interface research. Future soldiers may use BCIs to control drones, robotic vehicles, or communication systems without physical controls. However, this raises important ethical questions regarding safety, privacy, and responsible use of neurotechnology. As exciting as brain-computer interfaces are, they also present significant challenges. Privacy is one of the biggest concerns. Since BCIs interact directly with brain activity, protecting neural data becomes extremely important. Governments and technology companies must develop strict regulations to ensure personal thoughts remain secure and cannot be misused. Cybersecurity is another major issue. If computers can connect directly to the human brain, they must be protected against hacking and unauthorized access. Future BCI systems will require some of the strongest cybersecurity technologies ever developed. Ethical questions are equally important. Who owns brain data? Can thoughts be recorded? Should cognitive enhancement be available to everyone? Could employers require workers to use BCIs? These questions will become increasingly important as the technology advances. Another challenge involves accessibility. Current brain-computer interface systems remain expensive and highly specialized. Researchers continue working to make them smaller, safer, more affordable, and easier to use for millions of people worldwide. Several major technology companies and research institutions are investing heavily in brain-computer interface development. Universities, hospitals, neuroscience laboratories, and innovative technology companies are collaborating to accelerate progress in this field. Experts believe that the next decade will bring remarkable improvements. Brain-computer interfaces may become smaller, wireless, more accurate, and capable of handling increasingly complex tasks. Future systems could integrate seamlessly with artificial intelligence, augmented reality, robotics, and smart devices. Imagine waking up and controlling every device in your home using only your thoughts. Imagine instantly translating languages through neural implants. Imagine restoring movement to millions of disabled individuals. Imagine learning new skills more efficiently through direct interaction between your brain and intelligent computers. Although many of these possibilities are still under development, progress is happening faster than ever before. Brain-computer interfaces represent far more than just another technological innovation. They represent a completely new relationship between humans and machines. For the first time in history, technology may allow direct communication between the human mind and the digital world. As artificial intelligence, neuroscience, robotics, and quantum computing continue advancing together, brain-computer interfaces could become one of the most important inventions in human history. The future may not simply involve smarter computers. It may involve humans and intelligent machines working together as one connected system. The brain-computer interface revolution has only just begun, but its potential to transform healthcare, education, communication, entertainment, industry, and everyday life is almost limitless. The future of technology may not be in our hands, it may be inside our minds. Rocket Brain PC Robot.